Alright folks, let's give example 2 a try. Now these proofs in this section will start the same way they did in the previous. We're going to start with our given information in the first line. So let's write down RT equals 5, RS equals 5, and RT is congruent to TS. Now before we go on, let's mark the diagram. Marking the diagram will give you a good visual as to what's happening and will give you a better idea of what statements to write. I always recommend that students mark the diagram with the information provided so that you have a better idea of how to proceed. So let's do that. RT is 5. RS is 5. And finally, RT is congruent to TS. Our goal for this proof is to show that RS and TS are congruent. Well, let's take a look. Well, these two are both 5. These two are the same. So this one should also be 5. Well, if this one's 5, then these are equal. They are congruent. So I think this should be fairly manageable. Let's see what we can do with our statements to show that RS and TS are congruent. Now looking at my first two equations, I can see that both of them are equal to 5. So I should be able to easily conclude that they are equal to each other. That's an example of the transitive property. Now this would also be a case where I would accept substitution. Since we are working with equality, we can consider replacing this 5 with the RS that is equal to 5. We can plug RS into this equation. So either transitive or substitution would be appropriate here. In the next line, I'm going to do something new that we haven't seen before. I'm going to take this equation and I'm going to turn it into a congruent statement. I'm going to say RT is congruent to RS. Since our segments are equal in length, we know that they are in fact congruent. That's part of our definition of congruent segments. Now that I've changed these into congruents, take a look at these two. RT and TS are congruent. RT and RS are congruent. So since TS and RS are both congruent to the same value RT, then those two segments, RS and TS, are in fact congruent to each other. Here is a case where transitive property is the only property we can use. We don't want substitution here because we are working with congruence. Substitution, recall, only works with equality. Alright guys, let's try the next one. Well, where do you guys think we should start? I hope you said the given information. So let's get it all in there. Angle 1 is congruent to angle 2. Ray AD bisects angle CAB, and ray BD bisects angle CBA. Take a moment and mark the diagram. See what you know and see what that tells you. Alright folks, let's see what you marked. First off, angles 1 and 2 are congruent. So we're going to mark those. Our goal is to show that 3 and 4 are the same, so we can't mark that yet. That's what we're trying to show. We don't know it at the beginning, so it shouldn't be marked. Alright, well, we've got the congruence angles. Let's see what these other statements tell us. If we have a bisector, what does that mean? Well, it means that it cuts the angle in half. It creates two congruent pieces. So AD, if that bisects angle CAB, that tells us that these two angles are the same. If BD bisects angle CBA, then these two angles are the same. Well, if these two are the same, but 1 and 2 are the same, then 1 should be the same as 3. If these two are the same, and 1 and 2 are the same, well then 4 should be the same as 1. Well folks, all of these angles should match up. We should be able to get all of them to be the same. So let's do that. Let's start with that first conclusion. We said 1 and 3 were congruent. And we knew that because we had a bisector. So we can use the definition of an angle bisector to make that conclusion. We use the same rule to get 2 and 4 to be the same. We had another angle bisector on the opposite side of our equation, so 2 and 4 should be congruent. Well, let's start combining things. If 1 and 2 are the same and 1 and 3 are the same, well, we should be able to conclude that 2 and 3 are the same. So these two statements come together here. That's the transitive property. We're going to add one more line. Since 2 and 4 are the same and 2 and 3 are the same, well, we should be able to conclude that 3 and 4 are the same. Again, that's the transitive property. All right, folks, we have one left. The last proof says that MI and LD are congruent. So I'm going to mark that on my diagram. And I know that I want to start with my given information. So given the fact that MI and LD are congruent segments. My goal is to get ML, so this one, congruent to this one, ID. Now this is actually very similar to some of the proofs we did in the previous section. We see that they have this in common. So in order to get the whole lengths the same, we might have to do some segment addition and some regular addition to get there. If I add these two segments together, it should be the same sum as these two segments added together. But before we can do any addition or subtraction, multiplication, any of those algebraic properties from the previous section, we need to be in equality. Those properties from section 5 only worked with equality. They did not work with congruence. We start with congruence here, so we have to take an additional step to get to our equality. But doing so is pretty easy. I'm going to take one step and say that these two are in fact equal instead of congruent. Any thoughts on what the reason should be? We used it in example 2. We said that if two things were equal, they were congruent. If two things are congruent, then they're equal. That's our definition of congruent segments. Now that these two are equal, I'm going to give you a chance to try it. Think about the proofs that we did in section 5 and see if you can get these two segments, ML and ID, to be equal in length. After you have them equal in length, change them back to congruent. When you're done, make sure to check the answer with the answer key, and then you are finished.